Do you remember at the very beginning of this whole unit, I put this on the board? Thank you for that blue sheet. Okay, good. Thanks. I put this on the board and we said, okay, organic chemistry is the study of molecules that are made up mostly of carbon because they're life-based. And we said we are going to concentrate on hydrocarbons, by definition are? Special word? Try. Only. Only hydrogen and carbons. Nothing different. And hydrocarbon derivatives. Can you think of a derivative that we've already encountered? That's not only hydrogen carbons, but is mostly hydrogen carbons and a little something else? Come on. Like a chloro something or other, right? What do we call all those things? What's that group that they're a part of? Haloalkanes or haloalkenes or, right? Okay, so that's an example of a hydrocarbon derivative. Another one would be alcohols, we'll do those. Carboxylic acids, we'll be doing those. Esters, we'll do those too. Second half of the unit. We've already kind of done that one though. That's a hydrocarbon derivative. Hydrocarbon, hydrogens and carbons only. So there's two aspects of hydrocarbons. One are aliphatics and one is an aromatic. The aliphatics were the alkenes, alkanes, and alkynes. The first one we did was alkanes. We looked at naming, physical properties, general formula, chemical properties. We did the same thing for alkenes. General formula, naming, where they're found, information, reactions, and physical properties. And same with alkynes, basically naming, chemical properties, physical properties. Okay? So those are aliphatics. We're doing aromatics today. Okay? All right. It's good to know the categories. Everybody see where we're going and everybody see where we've come from. So you can kind of have these in your head as little sections. And then when you read a question, you ask yourself, what section does that apply to? Which then allows you to name it properly or talk about the chemical reaction properly. And it's one way of making sure you don't get mixed up between substitution and elimination. Because your head is in alkanes or alkenes, not kind of everywhere. Okay, so today's package is about aromatics. Oops. Okay, so what is an aromatic? Well, aromatics come from, by definition, aromas. Okay, so that's how they got their name, is because they all have an aroma. Some of them are nice aromas, but I gotta tell you, most of them stink. Like moth repellent is an aromatic, right? It stinks. But it definitely has an odor, albeit pungent. So they include a benzene ring. Okay, so what is a benzene ring? So benzenes have the general formula C6H6. So once upon a time ago, scientists knew that there was this compound that existed. They knew it was nonpolar. They knew, and it had the formula. They knew C6H6. Okay, so they put their minds together and thought, how can you get C6H6? Not an alkane, CnH2n plus 2. Not an alkene, not an alkyne, right? So they're like, ugh. And they figured out it has to be in a ring. So 1, 2, 3, 4, 5, 6. With one hydrogen off of each carbon. 1, 2, 3, 4, 5, 6. And then to fulfill the octet rule, you would need double bond space, double bond space, double bond space, double bond space. So this would be 1, 3, 5, oh pardon me, it'd be cyclo, hex, 1, 3, 5, triene. Everybody okay with that? Cyclohexene, but the double bonds are on 1, 3, and 5. Okay? But here's some information. So they knew if it was cyclohex 1, 3 triene, they knew that this site would operate like an alkene. So when I'm reacting, it should be an addition reaction. Open up the double bonds, 2 things to add. They knew that this site should be a substitution reaction. So I could substitute one for the other. But they found out that actually, no, it wasn't like that. It didn't have both styles. They were all substitution. really? But if I break that double bond, shouldn't I be addition, not substitution? So that was one problem that they had, evidence that it couldn't be cyclohex 1,3-triene. The other thing, the other piece of evidence, there are quite a few pieces of evidence, but here are the two main ones, that the bond length here is short on a double bond. Double bonds are quite short in bond length. Here is longer. So let's say this is a unit of 1, and let's say this is a unit of 2. And they found, they would have expected short, long, short, long, short, long, when they were measuring the bond lengths. But instead, they got somewhere in the middle, like a 1.5 all the way around. A little bit more than that, like 1.7, all the way around, 1.7, 1.7, all of them equal length, all of them. So they had to put their minds together, like, what is going on? Remember how I said that the single bonds are sigmas, and then this extra double bond is a pi bond? Remember saying that? Well, these extra pi bonds are so close to each other that they actually overlap. And this pi bond then would overlap with this pi bond, and this pi bond would overlap with this pi bond. And what you get is you get a whole region that operates all together. So what it looks like, if you were to draw it, it looks like a donut, circle, pi bond with a hole in the middle, the sigma bonds, and then a whole other donut on the bottom that's another region of pi bonds. So we have to signify this circular overlapping of the pi bond with, well, a circle. So that's where this comes from. It's a circle. That means I'm overlapping all of these pi bonds so they end up with one ring cloud in the middle, both top and bottom of the structure. Okay? So that's what that's trying to say to you. And on each corner I have a carbon and one hydrogen. So carbon, 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 just like our skeletal diagrams. Only here it's not 2, as you might have thought last unit. It's just going to be 1 because that is occupying a pi bond in every other space, basically. So H, 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 H. And that is benzene. Everybody okay with benzene? So C6H6 looks like that. That's what the circle means. It's unique, it's special, and therefore it's given its whole other category, aromatics. It's not an alkane, it's not an alkene, it's not a cycloalkane or cycloalkene. It is on its own. Okay? So that's why it's a whole other subtopic. Everybody all right? So all bonds equal is the next line, and there's an equal sharing of valence electrons by 6 carbons. So we've got to give it its whole other naming system. Well, this is kind of where it gets a bit tricky. Sometimes it's a branch, sometimes it's the main star attraction bracelet. Before we had methane, methyl, ethane, ethyl. No problem, right? Butane, butyl. Here we have benzene, phenyl. Weird, but you just got to deal with it. So if it is the main star attraction, I'm going to name it benzene. So let's just look at these ones. Main star attraction. Here's my benzene, my bracelet. Here's my charm hanging off of it. So it's called methyl benzene. Everybody fine with that? AKA toluene. Do you know what toluene is? You know those permanent markers that have that smell?
Mr. Sketch?
Not scented ones, not raspberry, but I mean like a Sharpie smell. Any permanent marker has that unique smell that's a little bit like, well, like gasoline, but not. It's toluene. This is what it looks like. So a solvent in a permanent marker is toluene. It's not water-based because you want it to be permanent. You don't want it to wash away. So you can't make it water-based. Yeah. Davin's got a Sharpie. You can pass it around and have a sniff. So that's, we call it toluene, but its IUPAC name is methyl benzene. Everybody okay with that? All right. Go ahead. Smell the Sharpie. Don't smell too much, though, because benzene on its own is carcinogenic. What's carcinogenic mean?
Cancerous.
Cancerous. Cancer-causing. So you don't want to be, it's fine once in a while with methylbenzene. It's almost fine once in a while with benzene, but don't tell anybody. But it's not, it's a carcinogenic, or benzene itself is a carcinogenic compound, so you don't want to be exposed to it a lot. Methylbenzene isn't that far different. So it's not cancer causing, but it's not great for you. And you certainly wouldn't want to be an artist stuck in a room full of constantly drawing diagrams or whatever you're employed to draw all day long without proper ventilation. Okay, but once in a while using your Sharpie, not a problem. Okay, 1-methyl, 3-ethyl benzene. Everybody see where that naming came from? Everybody see where the 1 and 3 came from? Anybody see a problem with that name? There's a problem. Should be in alphabetical order. 1-ethyl, 3-methyl benzene. Alphabetical order. Doesn't matter which one you call 1, as long as you call one of them 1 and one of them 3, because it's a circle, you move it, same thing. So this is a little bit different than our cycloalkenes, where the double bond was the priority of carbon 1 and 2. Remember that? So when we had a cyclo compound, the double bond in there made this have to be carbon 1 and have to be carbon 2. That was a rule for naming cycloalkenes and alkynes. But here, they're all even. So because they're all even, it's kind of like a cycloalkane. When we name it, we can make any of these 1. So you could choose to say 1, 2, 3, or 1, 2, 3. Doesn't matter. So 3-ethyl, 1-methyl benzene is appropriate as well. You with me? It's a long day. I know you guys are having a long day. Okay, so except for this. All right, so sometimes benzene isn't the main bracelet, but is rather more like a charm. And if it's the charm or the branch, we have to call it a phenyl. So here, this is our bracelet. And this is our charm. Do you see that? Do you see why we can't call it, what would we call it? Prop-YL-benzene. P-E-N-Z. Do you know what propylbenzene would look like? What would propylbenzene look like? We would first draw the benzene, and then we draw 3 carbons off of one of them, right? 1, 2, 3. That looks different than that. This looks like a T intersection. 1, 2 out of the middle carbon. See how that's different? So they are different, they'll have different boiling points. We'll have to name them differently. Okay, so this is phenylbenzene. So I have to name this one differently. So what I'm going to do is I'm going to call that my bracelet, this my charm. So this is propane, like it was always. And this, my charm, is phenyl. And it's with a YL like every other branch does, so that's helpful. But this whole changing bens to fen is just something you're going to have to cope with. Okay? It's so good that you're great with your aliphatics. So that's secure. Naming alkanes, done. We just need to conquer this. Okay, so bens to fen, 2 more. And I've got the number 2 because it's on carbon 2, just like our naming from before. Okay, and here's a unique. Remember how we have to know all these names? Okay, so this is a unique name. It's called phenol. I decided to chuck it in here. So this isn't called I don't know, hydroxybenzene or something. Maybe you want to call it hydroxyl benzene. Thinking that that's a charm off of this brand. It just has its own special name. It's phenol. And phenol's super important in chemistry because that ring structure is nearly unreactive. Benzene by itself, nearly unreactive. That donut in the middle is so stable. Nothing can kind of get it to break. So there's no addition, there's no, okay? But if I add a phenol to it, for reasons I won't go into, it kind of it does destabilize that ring and makes this thing a little bit more reactive. So if I'm wanting to make moth repellent, if I'm wanting to make refrigeration coolant, if I'm wanting to make toluene, I'm going to start with phenol instead of benzene. So in university, you'll see this a lot as the starting for your reaction, because it is reactive, whereas benzene, not so much. Okay, so it has its own special name, phenol. Just like ethylene, ethene, special name. There's only a few of them I expect you to know, so there's another one. Okay, so physical properties. Well, there's the boiling point, there's the melting point, so that means that it's a liquid at room temperature, which is great because it acts as a great solvent. Oh, it did until we figured out it was carcinogenic about 15, 20 years ago. And we kind of went, oh, I guess we're going to have to use something else as our solvent. So when we wanted to dissolve something, but it was like an oil base, we would use benzene to dissolve it. So we were using benzene in an organic lab like other chemists use water as their solvent. Do you see that? Because water's polar, so it dissolves polar things. Great if you want to make a solution of copper sulfate. If you want to make a solution of any organic compound, you would add benzene to it to dissolve it before you then reacted it or whatever. And so and then we found out it was carcinogenic, and they had to change things slightly so that they weren't using quite as much of it. If any, actually, it became quite like a lockdown. But it is nonpolar, and it does act as a great solvent for other nonpolar things. Remember like dissolves like from Chem 20? Physical properties, relatively stable or unreactive, but it's highly flammable, which must mean it's very volatile, a volatile liquid. But volatile doesn't mean flammable, remember? What does volatile mean?
It can react.
Evaporates easily. So therefore it reacts easy. It evaporates easy. We used that term a lot yesterday when I was talking about put your stoppers on because it's too volatile of a liquid. I wasn't worried about you blowing up the lab. I was worried about the fumes getting to my head by the end of the day. So if you don't know what volatile is, quick, write it down on the side of your sheet. Volatile is evaporates easily. And that makes you a good student. Okay, that donut, that ring structure likes to remain there, so it will be the last thing to react, and it undergoes substitution in the chemical reactions, not, as we said, addition as you would expect with a double bond breaking. So if I were to react benzene with bromine, I would end up with a substitution. Remember, there's a carbon with one hydrogen off of there, so the hydrogen comes off and becomes this hydrogen over here and bonds with the other bromine. HBr formed, as per the quiz I just handed back to you. Right? Happy? Okay, it's a versatile compound because it's used as the starting material for many things. And part of my proof, part of my thing about this unit is to say, look at how important it is. This is why we're learning it. Because it is everywhere, you just don't know it. So, for example, here it is in aspirin. And if you have a good organic chemistry program, you will make aspirin in your first year, or Tylenol. It's the same type of a procedure. And so you can see that you start, in fact, actually, you should start with phenol, but anyway, you can see that the benzene ring is the core to this. You've got a carboxylic acid added, like vinegar is a carboxylic acid with COOH at the end. And this is an ester, which is, looks like this. There's an ester. We'll be doing esters at the end of the unit. And so this is called acetylsalicylic acid or aspirin. Okay? Important. Here, this is DDT. Do you know what DDT is? Hands up if you've heard of DDT before. What is it? It's a pesticide. What's bad about it? Causes alteration of genes in the offspring, I believe. Is that right? So therefore, like the eggs of the birds that have been sprayed in this area end up being weak eggs. Like not crack, crack, but sponge, sponge. Weird, right? And the offspring of humans end up with deformities, if not massive miscarriages, because they're too deformed to actually grow and survive. So, but in Calgary they used to use this. When my mother was a little girl, she remembers it being sprayed down the streets. So the big, those big water trucks with the big like spray thing at the back. So they would drive one of these things down the street and literally spray it at the back of the truck, this big spray of DDT into the front gardens. So the front gardens were all, or front yards you say here, so the front yards were all sprayed with DDT. And it was hot summer days, so the kids would all come running out of the house and go running behind this truck in their sprinkler of DDT. Yeah, this was normal in Calgary. And then they found out the kind of deformities the DDT have, so now they still use it, but just not in Calgary, because tough luck with your mosquitoes. But in other places that carry malaria with these mosquitoes, now the disadvantage of malaria is outweighing the potential possibility of the defects. And so therefore they still use it, but only in areas where they have to use it. So it's like there's a special word that I just can't think of it, cost analysis, I think is what it's called, cost something. Social studies term. Anyway, where you look at the cost of using it versus, Anyway. Okay, but why is it called DDT? This is dichloro. Can you see the two chloros here? Dichloro. Diphenyl. Can you see the two phenols? Phenyl, phenyl, chloro, chloro. Trichloro. Here are those trichloros. Ethane. So here's my charm. And those are all the branches. So di, tri, DDT. Same thing with TNT. Who's heard of TNT? What is it? It's an explosive. What does the TNT stand for? Well, trinitro. By the way, these should all be twos. Trinitrotoluene. Remember how that's toluene? Methyl benzene is toluene. So here's trinitro-toluene, TNT. And again, this is an aromatic. So all these things are aromatics that exist in your, well, hopefully not every day. I'm hoping not DDT is your everyday life, but anyway. Yep. And for some reason I printed the same sheet twice, just because I loved it so much. Okay, let's practice. Try the first one. You've got like 4.8 seconds, and I'll put it on the board. Is that what you got? I said 4.8 seconds, Bert. You need to get your pencil before that.
Too fast for me.
Too fast for you?
Yeah.
Doesn't matter where you drew your methyls as long as they're right beside each other. Because it's a tire and it can turn. Right? Next one. Is that what you got? Good. Let's do 3 and 4. with Snyder Graham? Okay. Okay, here's a question for you. Pencils down for a minute. Whereabouts are you, Melissa? The question you want? Okay, good. I'm gonna stop you. All right. So, quite often they say write a balanced chemical equation for the combustion of 1,2-dimethylbenzene. Okay. So you're going that plus that goes to this plus this, and then you're thinking, how do I balance it? Right. But you have to know how many carbons and how many hydrogens are in here in order to access the balance numbers for there. Everybody okay with that? So what is, for some reason, like it's easy, you find it easier for you to figure out the molecular formula for an alkane, alkene, alkyne than you do for an aromatic. So what is the molecular formula, as in C, what, H, huh? For this 1,2-dimethylbenzene. C6H6 for benzene. Plus 2 C's for the branches. Plus, okay, you're not done yet.
Plus the 6
No, that's, what did you have to do to that benzene to stick the methyl on? Take off the hydrogens that were on there. So C6H6, where that was an H, but then you had to take off the H to put the methyl. So I've got to take 2 away from there. You see that? And so then we go, yeah, okay, I've got 8 hydrogens, and I've got, or pardon me, 8 oxygens, and I've got 10 hydrogens. Not 6 and 6, 12 hydrogens, which is what you probably would have said. Does that make sense? And now it's easy to balance. So it's important to come up with a molecular formula for these, otherwise you struggle. So let's do the molecular formula for C then. Oh, I know, let's not do C. Let's do D, because it's completely different. So the molecular formula for D. Gabby? Engage. Heads up and thumbs up if you got it right. Good. Good. Okay? Just takes a little bit of conscious thinking to go through those, and then you're fine. It's not hard. Just takes a pause to think about it. That's all. All right, so I think we can practice the rest. Oh, B. Let's jump down to B for a second. How are we going to name B? Longest chain. It's not 4. First is the rule that the longest chain must have your multiple bond. Remember that? So right away, this becomes the bracelet. And this is the charm. Okay, because it's not propylbenzene, because propylbenzene wouldn't have a triple bond there. So then this becomes prop 1-ine. I have to put the number in because there's a difference between prop 1-ine and prop 2-ine. If that was a single bond and that was the triple bond, it'd be different. So I have to put the number in. Pardon me?
Would that still be prop 1-ine though?
Aha, so, yeah, and when you're naming just propyne by itself, Absolutely, it doesn't matter when it's just propyne, propyne. But once it's 1-phenyl propyne, these are not equal. They will have ever so slightly different boiling points, reactions, etc. Ever so slightly, but they are different, and therefore they have to be named different. So therefore this would be 1-phenyl prop 1-ine and 1-phenyl prop 2-ine. If you can't see that they are different, or like you're like, holy smokes, what is she talking about? I've already told you, always put your numbers in. I will never dock you marks for putting your numbers in. I will dock you marks. Oh, pardon me. You can't expect me to put the numbers in all the time. You do need to know that I sometimes don't put the numbers in. But you can always. You'll get full marks. Okay, so 1-phenyl prop 1-ine, not 1-phenyl prop 2-ine. But if the phenyl was here, now these are equal. And that would be called 1-phenyl prop 1-ine as well. Haha. Have I suitably scared you? Fear not. Okay, so keep going, examples, practice, some more practice, and then hey, I thought it was about time that we threw some diploma questions into this so that you could see the style that was asked of you and required for you to know. What's the matter? Don't worry. Don't worry. So for example, here's a diploma question. I don't know if this one I included, but here be an example. Let's go back up to this sheet. Here are the following names. Okay? Of course, it's always multiple choice numeric response, but anyway, let's not play that game. Let's say it's a circle option. Circle the aromatics on this page. Have I got to any yet? Let's go down to question 2. Circle the aromatics on this page. So what's an aromatic again? Pardon me? Contains a benzene. So here's an aromatic, here's an aromatic. Oop, no. Oop, no. Here's an aromatic. Okay. Asterisk the aliphatics. Here's an aliphatic, here's an aliphatic, here's an aliphatic. Okay. Put a triangle around an alkane. No, no, no. Definitely. So this is definitely an alkane. Is this an alkane? It has its own special word. It's a cycloalkane. So it's not an alkane. Okay? No triangle for this guy. He's not an alkane. He's a cycloalkane. He does not follow the rule CnH2n plus 2. He follows the rule of CnH2n, like an alkene. He's special. So no triangle for him. Okay, so that's a type of diploma question. What is the correct name for this one? A 1-phenyl prop 1-ene, or ine I mean. B 1-phenyl prop 2-ine. C 2-phenyl prop, I don't know, whatever, right? Some other ones. Pent. They'll probably put a pent in there because students always mix up prop and pent. Get it? So just a bit of a flavor because these are completely different. These are just understanding it. So don't worry about the diploma questions, but I thought it'd be nice for you to get how they word it, how they ask it, and therefore extract the same knowledge into multiple choice. Okay? All right. Okay.